Hi, my honors class. We are doing 17.1 today. 17.1 is on proportions. Proportions are two ratios that are equal. So if I have like 3/5 and I set that equal to 9/15, that's a proportion because I have a ratio equal to a ratio. And you can see that there is a scale factor of 3/5. If you multiply or if you grow that side, which it means that if I have two triangles that are similar and one is 3, one side is 3, and the other side of the other triangle is 5, then if on that same triangle, because we're dealing with the tops here, 3 and 9, if one side is 9, say this bottom side is 9, then the bottom side of the similar triangle must be 15. And anyway, the proportions are equal. And say this side over here is 4, then what would this side be? Well, because of the fact that triangles grow at the same rate, and you're noticing that we have a multiplier of 3, so we're 3 times bigger for each of the sides, then if I take 4, then multiply it by 3, I get 12, which would be the measure of the side that's proportional with 4, that's corresponding to 4 on the similar triangles. So each time you're multiplying by 3 and you're guaranteed with similar triangles that each of the sides are indeed multiplied by 3. And with that, we can solve for sides that are missing or unknown. We can solve for perimeters if we're unknown. If we don't know the perimeter, there are a lot of things that we can use similar triangles for. They use similar triangles a lot when they're doing indirect measurements. Say you're going to go on a little hike and you want to cross a river and you're not sure how far it is across, and it looks like you can cross it, but you want to measure it first. You can use similar triangles, and eventually you'll be dealing with trig and other things, but similar triangles are the bomb because we can use them all the time to find unknown measurements. And for that, we use proportions, and that's what we're going to do with this lesson is we're going to learn proportions and how to deal with proportions because they'll be useful when we're looking for sides of triangles that are similar. All right, so remember that if I have 2 times 1/5, that is the same thing as a fifth plus a fifth, which is 2/5. All right, and then if I have 2/5, I can also take, in order to come with 2/5, I can also take 2 times 1/5, and 2 times 1/5 is going to be, remember you multiply straight across, so 2 times 1/5 or 2/5. So in both cases, whatever you're doing, you get 2/5. Now fractions, when you're multiplying, you would do the same thing here. I would have 4/7 plus 4/7 plus 4/7, or I would have 3 times 4/7. In both cases, 4 plus 4 plus 4 is 12. 3 times 4 is 12. I have 12/7. Okay. I don't know which way you like the best, but I'm not going to write the next one out. Just note that we can take 11 times 6/11, and that's going to be 66/11. We also know we can divide out the 11 because there's an 11 multiplied on top and bottom, and we get 6. All right, so those are just some little things to remember while we're solving fractions. Fractions are probably the most feared or disliked type of mathematics out there. But anyway, that's what happens when we're dealing with similar triangles. Now, if I have x over 3 equals 4, then I know for sure that I'm going to multiply both sides by 3. I multiplied it in my head already, didn't I, like I usually do? All right, so 3, you need to multiply both sides by 3, and you get x equals 12. All right, and that's one way to solve. When we have a fraction equal to a fraction, a ratio equal to a ratio, then that is a true proportion right there. And that's the definition of a proportion. 2 equal ratios equal to each other. So when we do that, we cross multiply. Now remember that we only cross multiply when we have an equal sign in the middle. So we have to have that equal sign in the middle. So 1 times 6 is 6, and 2 times x is 2x. We divide by 2, and our x is equal to 3. All right, and then likewise with the next problem, 4 times x, it's a cross multiplier, and that's going to be equal to 16 times 5, which is 80. And if we divide both sides by 4, we get x equals 20. And that's solving proportions. All right, and then looking back, is the answer to number 2 a fraction? Why or why not? I would say probably the answer to number 2 is a fraction. A fraction is anything that can be written in a form of a over b. In this case, it's 6 over 1. So I would say yes, and it's because 6 can be placed over 1, and therefore making it a fraction. All right, next up, looking back at exercises 4 and 5, can we think of another way to solve them? On 4 and 5, I'm not going to actually go through that because I'm running short on time, but if you can, go ahead and figure out another way that you can maybe solve those. And then note that fractions have their own little properties. And if you have b, if you multiply both sides by b, then that's going to be equal to a equals bc over d, or dA equals d over bc over d, and then AD equals bc. These are all different properties that you can use. We don't generally use that. What they call this are the means and the extremes, and there are a lot of things that are dealt with when you deal with that. And that just means that if I take A times D, and that's equal to B times C, and a cross product is easiest to solve. All right. When you're looking at example 1, I'm sure you can do these with me. That's pretty easy. We've already done a few. 21 is equal to 4x. I love this new little toy because it just keeps popping up things that I don't mean for it to pop up. And I have to remember to keep clicking the pen all the time. All right, so if I cross multiply, so 7 times 3 is 21, x times 4 is 4x, and I divide by 4. Oh no, what happens? You see x equals 21 fourths. Does 4 go into 21? No, but that's all right. We'll just leave it like that. 21 over 4 is a fraction, and it's in simplest form, and it doesn't divide out evenly, so it's all right. You could find a decimal for it. It's 5.25. Those are exactly equal. It's a terminating decimal, so we don't have to round, therefore it's equal. It's all good. All right, now when I have x plus 8, that's a binomial. So that means there are two parts to it. There's an x and then a plus 8. So a lot of times when I'm performing these, or what I'm going to ask you to do is put parentheses around that x plus 8, or any binomial whatsoever. Over here, I would put parentheses over the x minus 2 and the x plus 3. That reminds us that when we multiply by 8, we have to multiply the entire entity by 8. So what that means is 8 times x plus 8 is equal to 3 times 7. Okay, so when you multiply those, make sure that you multiply 8 by both x and by 8, which makes 8x plus 64 is equal to 21. So be careful with that. That's one of the most common mistakes. And then subtract 64 from both sides, and we get 8x is equal to negative 43. Oh no, it's another fraction, isn't it? So 43 divided by 8, there's nothing common because, oh no, 8 doesn't go into 43. 43 is prime. So x equals negative 43 eighths, or if we want to give it in a decimal, it's negative 5.375. Right? Whichever one they ask for, give it to them. Most generally, if they don't say, I just leave it as a fraction. All right, here we have 6 times x plus 3 is equal to 2 times x minus 2. So 6x plus 18 is equal to 2x minus 4. If I subtract 2x, I get 4x plus 18 is equal to negative 4. And subtract 14, I get 4x is equal to negative 22. And if I divide by 4, I can simplify, but it's dividing out of 2 leaves it still as a fraction. So negative 11 halves, or negative 11 divided by 2 is 5.5 as a decimal. All right, so that's how you do that. And let's see. So you can go ahead and do the assignment 7-1 after that. I did want to go back to this really quickly. I like that they put this in, but we're not really going to worry about it. Just note that this cross product is what we're going to do to solve. So we're not going to multiply both sides by A and or B or D. And anyway, so don't worry about that. All right, go ahead and do the assignment. Have a good time and stop by for 7-2 next.